A form is only as good as the data it collects from your user. Allowing your users to submit forms with required fields left blank or not checking that an input's content is what you're expecting can lead to unusable data and unreliable databases. Simply put, a form that does not collect the data that you need as you need it is not serving its full purpose. In this course, we're going to learn how to validate any form inside a Vue-3 application by leveraging the power of Vue-Validate. Form validation can get very complex very quickly. To do it right, you'd need to handcraft everything from connecting your inputs into a central parser to check the validity of your data, to creating custom roles and handling different input states. While you could do that all from scratch, your precious development time is better spent on building application logic, polishing the user experience of your form, and ensuring it's highly accessible. By implementing a plug-and-play solution like Vue-Validate, you'll free up more time that can be devoted to these considerations. Throughout this course, we will learn how to use Vue-Validate and validate both a single input in our application and then grow that to validating a full form with a defined set of rules. Next, we will learn together how to check and present validation errors to our users as they progress through filling out our forms. We will explore the different ways of obtaining information about the state of our forms. For example, how to tell when an error is present within a field versus extracting all of the form's errors at once. Later in this course, we will explore the benefits of using an out-of-the-box validations method library, YUP, and its benefits as opposed to writing your own. We will implement and understand together the library's best practices, such as how to handle form submit events or the benefits of lazy versus aggressive validation. So if you're ready to feel confident validating any form with this handy validation library, I'll see you in the rest of the course. In this lesson, we're going to get started with Vue-Validate and validate our first form fields. If you haven't done it already, please grab a copy of the course's repository from the lesson resources below. I've set us up with a sample login form that includes an email and a password field. For the sake of continuity, we're going to be using the components we created in Vue Mastery's Vue-3 form course, but you can use your own form components if you prefer. The details of how the components work are not relevant for this course. It just needs to be able to V-model its state to its parent. Also, it would be a plus if it's able to display labels and error messages. With that out of the way, let's get set up by adding Vue-Validate into our project. First, run the following command in your terminal. There are two ways that we can use Vue-Validate in Vue-3. Through a template-based component that is provided to us by the library called Field, or through the use of Composition API. The component approach is the simplest way of using Vue-Validate, but it does require us to use their pre-bundled input component. Since we want to leverage our custom-made components and have as much control over our form as we can, we are going to use the Composition API approach. The library exposes a few intuitive composition functions that allow us to define which pieces of data on our state we are going to use as fields, which need to be validated. If you have never used the Composition API before with Vue-3, this would be a good moment to take a look at the Vue-3 Composition API course here in Vue Mastery before the rest of the lesson. Let's head over to loginform.vue and start working on validating our email input. Notice that we already have a setup method where we are declaring an onSubmit method, so that our form's @submit event has something tied to it. Let's start by importing the composition function, useField, from Vue-Validate. The useField function tells Vue-Validate that we are creating a form field that we want to have validated. In its simplest form, it accepts two parameters. The first one, a string with the name of the model for this field. In our case, we will simply call it email. The second parameter is a function to check if the value of the field is valid or not. Let's use this function to set up the validation for our email input. We will create a constant email and call the useField function. The first parameter will be a string email, and the second parameter a function that receives a value. We will check if there is no value. In that case, we will return this field is required as a string. Else, we will return true. We have set the name email for our model of this input, and we have created a new function that will validate the email input every time it updates. Notice the form is receiving a value param. We then check if this value is empty, and if it is, we return a string with an error message. Validation functions in vValidate can return either true to indicate that the field is valid, or a string that will represent the error message we will display for the user. Let's take this a bit further and use a regular expression to check that the value is a valid email address. I'm going to paste here the regular expression to check for a valid email address. We will then return an error if it doesn't match. Here, we are checking to see if the value that we are getting from the email field passes the regular expression test. If it doesn't, we return a different string with an error that clarifies what we want from the user. This gives us the flexibility to do all types of checks and validation here for our fields and return a different error message for each one. Notice that we are currently saving the result from the useField method in an email constant. This email constant is an object that contains two very important properties. The first one, value, is a Vue-ref or reactive value. We will use this value to keep the data binding between our input component and the state. Let's use this value property of the email object to vModel bind our input in our template. First, we will return the email.value property from our setup function so that we can use it in our template. We are exporting this value property as email so that it is clear in our template what is happening with the binding. We can now go to the template of our .vue file and add a vModel binding to our base input for the email field. We will bind it to the email ref we just exported in setup. Let's scroll back down. The second important property that the useField function gives us is the error message property. Whenever our validation function fails and returns an error message, it will be stored in this property of the email constant. Let's return this property as well in our setup function and bind it to the error prop of our base input component. We will return it here, scroll all the way up, and then bind it to the error property. If we go to our browser now and check this out, we'll see that as we start typing, the validation fires. Since we're not entering first a valid email address, the email property is set and our error message is displayed. It also updates to a valid email as I type it. This is working great so far, but I want to do a bit of cleanup with how we are setting up our email constant and briefly talk about JavaScript destructuring. Notice how the useField method returns an object. In this object, there are quite a few properties, and we're capturing them all as a full object inside the email constant. Then, we go ahead and access those properties in the email object of our return statement and pass them to return like so. This is perfectly okay to do. And this verboseness can sometimes lead to code clarity, which is always a good thing. But often, when working with the composition API, you will notice that most resources will make use of JavaScript destructuring. Destructuring in itself is beyond the scope of this course, but MDN has a great article that explains it in detail. It is linked down below. The previous example, written using JavaScript destructuring, looks like this. We will remove the email constant and extract value and error message. The property value and error message of the object returned by useField are now readily available to us as variables, so we can pass them directly into the return statement. There's one last bit I want to show you before we move on. There are times we will need to rename these properties for clarity, or because they may conflict with one another. In JavaScript, we can rename a destructure property by adding a colon after the property in the destructure syntax and the new name. We will first rename value to email, error message to email error, and now we can return the renamed versions. Both syntaxes are completely fine, so feel free to use whichever makes more sense to you with our examples. Now that we've successfully validated our first form component, we are ready to move on to the next lesson and take a look at defining our validations at form level using a schema. See you there. Now that we know how to validate a single input field in our forms, let's take it a step further and learn how to set up validations at the form level. This will allow us to define rules for our whole form at once without so much code clutter. If we were to continue with the current strategy, in order to validate our password field, we would now need to add a new use field call for it. In a form with two fields like this login form, this may not seem like a big issue since it's only a couple more lines of code. But when we are dealing with a substantially bigger form, like a registration form, for example, this can quickly become hard to manage. Luckily, there is a very similar way to declare how we want our forms to be validated all at once, the useForm function. Let's first add to our import statement on the top of loginform.vue the useForm method. UseField and useForm are both imported from the vValidate package. When validating at form level, we want to create an object that will represent the structure of our form's model or data. This is usually referred to as the schema. We know that we have two things that we have to capture from the user here, the email and the password. So let's start by creating an object with these properties inside the setup function. Notice that each of our properties points to a function. This function is what vValidate will use when validating each of our inputs. Notice also that the function receives a single param, value. This value contains the data that the user is entering into our form inputs. We already have a function to validate our email that we wrote on the previous lesson. So let's cut it out of the useField call we had for our email input and paste it into our validations object. Notice that our useField call remains, but only with the first parameter, email. Be careful, this string email must match the email property of our validation schema. If the property inside of our validations object was called email address, for example, our useField call here would have the string email address instead to reflect it. Now that we've refactored everything, let's add the actual validation method for our password field. First, create a variable for the error message. We want to make sure that the value exists, so if it's undefined or null, we'll just return the error message. Next, we want to make sure that it has a length greater than 0. If that's not the case, we'll return the error message. And finally, return true. Now that our validations are ready, we have to tell vValidate that we want to use this object as the validations schema. We can do this with the useForm method that we imported earlier. The useForm method takes an object as its only parameter. Within this object, we can define several configuration properties, but the one that we are interested in right now is called validation schema. Let's set this property to our validations object. Now that vValidate knows how to validate our form's data, let's make sure that we are correctly binding the vModel for the password, as well as getting any possible errors. We're going to call useField for the password field to get back another set of value and an error message. Notice that we are using JavaScript object destructuring one more time to extract the value and error message out of the password field object. Let's also rename them to password and password error respectively so that we can tell them apart, and return them from our setup method so that we can use them on our template. Let's now go to the template and set up the vModel and error bindings for the password input. Fire up your browser and start typing into both your email and password fields. Notice how, as you type the first character, the validation triggers, and the methods that we added for each one respectively calculate if the fields are valid or not. Now that our form's validation logic is centralized, let's learn how to also centralize our error messages using useForm so that we don't have to call useField manually for every single field that we want to add to our form. We'll handle that in the next lesson. See you there. Welcome back. Now that we know how to handle validation on a per field level, we're going to take a look at validating a more robust, complex form. I've gone ahead and created a form for us to use so that we can get right into validating it. Please make sure to start with a fresh copy of this lesson's branch. Whenever the form submit event is fired, through a user clicking the submit button or hitting enter, for example, we want to make sure that vValidate runs all of our validations. If any of our validations fail, we want to display that error to our users. If all of our validations pass, we want to be able to use the form's data inside of our application to send it to the backend or anything else we need. Let's navigate into components-form.vue, where our form lives. Inside the setup method, you will notice I've created 3 validation methods: required, min-length, and anything. We'll cover this in a bit. It's very common when validating several fields to extract validation methods so that you don't have to repeat yourself. Even more common would be to use pre-made methods from a validation library, but more on that on a later lesson. Notice that for the required method, we first check to see if the value could possibly be undefined or no. If it is, then we return the error message. If it's not, then we check that the length of the string is not 0. If it is, then we have an empty string, and once again must return the correct error message. Only when both of these checks pass can we then return true and tell vValidate that this field is valid. Because we have these methods predefined, we can now assign the validation method that we want to each of our fields of our form. At the same time, we can create our validation schema like we learned in the last lesson. There are 2 important things here. First, our required method's first and only parameter is our value. Remember from the last lesson that vValidate will inject the field's current value into our validation methods. Second, you may have noticed that I created a validation method called anything that basically doesn't do anything other than returning true. In our current form, we have several fields that we don't want to validate. However, we do want vValidate to know about them as part of the form schema because we want to be able to send them out later on when we submit our form. Trust me for now when I tell you, you want to have all your fields declared on the schema in most cases. We have 2 options here. We can either declare a field as undefined, or we can have an empty validation method like anything. I personally prefer anything because it's clearer, but feel free to use either. For the title, we are going to look at how to assign 2 different validations, since you may want to perform several checks for each field. For the sake of this example, we are going to check that the title is both required and also has a minimum length of at least 3. We know that our validations return either a string when they are invalid or true when they are valid. So we first run our validations against the current value and capture them in variables. Next, we check to see if the required validator is successful. If not, we return its error message. Then, we use our min-length function to check that the minimum length is at least 3 and once again return the error if it's present. If both of our validations pass, then we return true to tell vValidate that the field is valid. Finally, let's make use of the useForm function to tell vValidate about our validation schema like we learned in the previous lesson. Since we're using useForm, we have to import it up here. And let's also import useField. We'll be using that next. We need to bind all of our fields to the template. For demonstration purposes, let's do it as we did before with the login form by using useFields. Don't worry, you can just copy-paste this incredibly verbose code. I've added a return object with all of the fields values and error message bindings. You can get the code from the text version below this video. I'm going to add the vModel bindings for every element in the template, along with their error binding. We're almost there. And here's the last one. Whew. I think this really puts into perspective what I was pointing out in the last lesson. The useField approach can be really repetitive and cumbersome to write. One thing I want to point out is that some of the fields like pets have extra parameters on them that we haven't learned about yet. The first parameter, pets, is the string that we learned about in the last lesson. It tells the useField method which property of our validation schema we want to use. The second parameter, which is currently undefined, is the validation method. We don't need to use this param because we already set our validation methods on the validation schema we created earlier. The third param is a configuration object. Amongst what we can set here is the property initial value, which lets us set the initial value for our field. I've added an initial value to our checkboxes and radio inputs so that they have an initial value on our state. Before we keep going with optimizing our code, I want to take a look at one of the most important parts of having a form and validating it. The part where the user submits the form to us. vValidate provides a method called handleSubmit that handles checking that the form is valid before submitting it for us. In order to get this method, we need to extract it out of the useForm composition function that we use to inject our validation schema. Now that we have handleSubmit, we can use it to set up or submit form logic. The handleSubmit method has one parameter, a callback function that will be executed if the user tries to submit a valid form. It will not be executed if any errors are present in our form, so we can be certain that whatever handler we place in here will contain valid data. Notice that the callback function that we are passing into handleSubmit will get a values parameter injected into it. This values is an object that will contain all of the property value pairs of our form's data, matching the exact structure that we declared on our validation schema. Before we can check the output from the console log though, we have first to return the submit function that the handleSubmit method generates so that we can bind it to a submit event on the template. Please note that we have purposely left out the prevent modifier from the submit event here, because vValidate will do this for us behind the scenes. Notice that we are using categories for the options here. We have to define the categories in the data before this form can be used in the browser. Now that everything is set up, Let's go back to the browser. Notice that if we try to submit the form right away, our validations are all triggered. This is a side effect that we get for free when using the handle submit method. Not only does it protect our callback from being triggered once the form is completely valid, but it also triggers all the validations on our form whenever the submit event happens, even on fields that the user has not yet modified. Here you can see the output of the console log with some dummy data whenever the valid form is submitted. Our code at this point works, but it's still looking a bit verbose. I want to show you an alternative way of writing this, which allows us to write fewer lines of code. The useForm composition function has yet another object we can extract that will help us reduce our code, the errors object. The errors object will neatly contain all of our error messages whenever they are present. So if the title input has an error, for example, then the errors.title will contain our error message. This allows us to first remove a lot of the code for the used field calls by removing the errors part. We can then simply return errors from our setup function. That is already quite a bit of code that we don't need to write. The only other change we need to make is in the template, where instead of binding the error property of each of our inputs to our all variables, we can now bind it to the corresponding property inside of the errors object. The error for title, title error, will instead be errors.title, for example. And here's the last one. One more little change that I want to make to tidy things up is to move the initial values of our form from the useField methods to the useForm method, so that we can neatly wrap them up also in one single spot. The first thing we have to do is set up our initial form values directly on our useForm methods configuration object, like this. Now that they are all declared here, and in a much neater way, we can remove them from our useField methods. Now that our form is ready and being validated, let's take a look at how we can save some development time and leverage some pre-made validation methods with Yup in the next lesson. See you there! Writing your own validation methods can be cumbersome and greatly increase the time required to get a validated form up and running. Additionally, you have to keep in mind all of the considerations that a single validation method could have. Let's take a look at our required method from last lesson as an example. At first glance, it would seem that this function is doing a very good job, but now compare it to this other function that does the same job. It seems like I have failed to think about quite a few edge cases. This is common when trying to reinvent the wheel with validations, which is why vValidate recommends as a best practice to use the library Yup in order to create our validation schemas. Let's check this library out together. To start using Yup, we have to first install the library into our project. After it's done installing the packages, we can go back to the components form and add the import statement next to the vValidate import. Yup has the ability to create both array and object-based schemas, but vValidate is expecting an object with a property for each one of our form fields, as we learned in earlier lessons. In order to accomplish this, we are going to call the object function within the Yup object we imported. Then, we'll set it up with an empty object that we will fill up with our validations. You use the Yup object, and then you append to it as many functions as you need that describe the validations you want for the field. Yup has a very straightforward way of defining the rules that we want for a particular field. Let's start with category. We declare the property category as we did before for our schema. And then with the yup object, append the string method, which means that we are expecting a string, and required, which means this field is required. Let's try it again for title. And this time we're going to set a custom message in case that there is an error. This time we have appended to yup both required with a custom message in case if it fails, and the validator min with a value of 3. This will make the field both required and have a minimum required length of 3 characters. Let's go ahead and fill out the rest of the fields. Notice that for location, pets, catering, and music, we are no longer setting them to undefined or an empty validation. We are setting them to check for the correct data type that we are expecting. This is not mandatory though, and you can continue to use undefined for your unvalidated fields. Go ahead and delete or comment out if you want the current implementation of validation schema. Now that we are done, we can go back to the browser and hit that submit button to trigger the validations, and everything should be working as before. Validations are in place, and as soon as the submit event fires, they show the error messages. Before we wrap up, I'd like to point out that we are importing the whole yup package in our example right now. This will definitely impact our bundle size. Since we are only using the object, string, boolean, and number methods of yup, let's go ahead and use destructuring so that when we build our application, the parts of the library that we are not using can be removed from the bundle, and we can save on some bundle size. This is known as tree shaking. Finally, we just have to remove the yup object from our code and use the imported functions directly. We have only begun to scratch the surface of what yup offers as a validation methods library. I highly recommend you go visit their GitHub page and scroll through the documentation to give yourself an idea of all the different validation methods that you can use within your own forms. In our next lesson, we will explore an advanced tip, lazy versus aggressive validation, and how to achieve it with Vue-Validate. A common requirement in forms is to have the ability to only trigger the validation of a certain field whenever the user is done typing. This is called lazy validation. For this lesson, we're going to be using our login form as an example. As one of the most used cases for lazy validation are email address fields. It can be quite annoying for the user when they begin to type in their email and the application is already complaining that what they typed is not a valid email address. Text and email input fields fire different events depending on how the user interacts with them. The input event fires every time the user adds or deletes a character into the field. The change event fires once the field loses focus. In order to provide a better experience for our users when typing their email address, we are going to learn how to validate our email field when the change event happens instead of the default input. Components that wrap form inputs, such as our demo base input, usually allow for a vModel binding to happen by a double-way binding into the model value property and listening for the update model value event. Internally, this update model value event usually fires when the input event from the underlying element happens. This is the case for our demo component base input. If you want to know more about how we built this component, check out the Vue-3 forms course where we'll build this component from the ground up. The first thing we are going to do is remove the vModel binding. So go ahead and delete that from the first base input instance that holds our email binding. Our component is no longer being bound to our state. So first, we have to reestablish the binding of the state into the component through our model value property. Next, we want to now listen to the change event of the underlying input of the component. So we are going to add a change event listener and bind it to the handle change function. We haven't created this function yet, but we will get to that right after. We need to inform vValidate that a change in our state for the email field has occurred whenever the user changes something in the field. Luckily for us, we don't have to write the logic for the handle change function ourselves, since vValidate provides it out of the box with the useField composable. Let's extract out of the useField composition function another property, handle change, which is a function. This function will handle all of the required logic for vValidate to update the state internally once it's called with a new value, which is exactly what our addChange handle change binding will do. Finally, we will return the handle change function we just extracted so that it is available to us in our template. Now that our bindings are set up, we can go back to the browser and check that everything works. If we start typing anything into the email field, we can see that the validation is not immediately fired as before. And when we tab into the password field or click outside the form, the change event is fired and the validation triggers. If your form consists of several inputs, the approach of using handle change for each one may become cumbersome, as we've learned in previous lessons. In these cases, we can use a different approach. There is a function named setFieldValue that can be extracted from the useForm composition function. With this approach, we have to create our own handle change function, which will accept the event object as a parameter, and in here we can call the setFieldValue function. This function allows us to pass two parameters, the field that we want to update and the value that we want to assign it to. You may be wondering why you would need to use this magic method instead of directly updating the form's model. The setFieldValue function will trigger the validation rules on the forms field who was modified, which would not be the case if we were to modify the state directly. For more information on setFieldValue, please check out the official docs. I've put a link down below. As we have learned, lazy validation is a very important tool when building forms. When used in conjunction with fields like email, it provides a polished user experience with a minimal change in our code's workflow. Writing your own valid Welcome back. Now that we know how to handle validation, Now that in this lesson, we're going to a